Welcome and hello. This is a video exercise in RIMS, and in this video I am going to be fuel blending. So typically we've been doing water resources related simulations and exercises. This one's going to be about fuel. So let me bring up the problem statement I have right here in Excel. We have 5 different types of raw crude which need to be blended in to create a total of 100 barrels blended crude. We'll just call it fuel. As you can see, here is the data table. So we have crude in the far left column, and then in the other columns, we have the specific parameters associated with each crude, A through E. So there's a cost, there's an octane level, there's a percent sulfur, and a percent benzene. So this is going to be your typical linear programming type problem, but we're going to use RIMS to solve it. And if you want to stick around towards the end, I'll also show you how to solve this problem in Microsoft Excel. Okay, so we're looking at RIMS though. This is the data, the parameters, and then down below here we have the constraints. So the total number of barrels we want to create is 100. And what we want to do, the optimization is to minimize the cost. I guess I didn't write that out here, but our objective is to minimize the cost and create 100 barrels. And then down below here, we have 3 different constraints. Well, total barrels is a constraint as well, but we have a minimum constraint, so a minimum of 85 octane. A maximum sulfur allowed is 70%, and then a maximum benzene allowed is going to be 80%. All right. So that's the problem statement. I'll show you how to set that up and solve it using the RIMS application. So let's open up our RIMS and then right click new to add a new project. I'm doing a right click over here in the project explorer. All right, so general and project. Once that's selected, click next. Then for the project name, I'm just going to call this fuel blending. And then project directory needs to go right here. For me, here's my project directory. I'm just going to copy the path in my Windows machine by selecting it, Control C. It's on my clipboard now, and then come back here to this location text box, paste it in, Control V, and finish. All right. So here is the project. There's nothing going on right now. So let's go ahead and start by creating a launch file. I'm going to go right click, run as, and then run configurations. All right. I'm going to click on Russell/RIMS2 application down here on the left panel, and then click on the new configuration. Okay. It likes to resize my configuration window. Up at the top, I'm going to give it a name. It's going to be E7 for exercise 7, fuel blending. And then the study, I'll just call it the same thing. The description, some of these are optional, but what's not optional is the main Russell file and then the DSS paths. These are relative paths. So from the main project directory, I'm going to put my main Russell file in a run directory and then main.wresl. All right, the DSS files are going to be in a DSS directory. dv.dss is where I'm going to write the decision variables after the simulation is run. That's where my results will be. The state variables and initial variable file I don't have for this project, but I'm going to just add them in here anyway because I think the RIMS requires it to run. Don't need a groundwater folder. And then for part A of the state variable, I'm just going to be generic, call it project, call this state and init for part F of the state and init DSS files. All right, the default is 1 month for this time range. I don't need more than one single time step because we're not changing anything, but I'll go ahead and just use an entire year, 12 time steps. Okay, so I'll select 1921 to 1922. It's going to be the same results for all 12 months. That's totally fine. All right, the next tab over is configuration. I'm going to click this checkbox here to enable the Russell Plus interpreter. And then the far right tab here in the configuration, run configurations dialog box is source. Oops, hold on. Common is what I want to select. And then click on shared, browse, and then select our project, which is right up here, E7 fuel blending. Okay. That's all I need to do. I need to click apply and then I can close this dialog box. So what happened there is I now have this launch file, which I can go right click and run once we actually have our files and everything else set up. All right, as far as files, this is the file structure that I'm going to build. This is the main project directory. We already have these files and I've already referenced the main Russell file and these DSS files. So we actually need to create the files and then we need to also populate some of those files as well, like the Russell files. So to do that, let's go to our project directory, which is right here. Let's start by creating our DSS directory. Oops, DSS. And then inside the DSS directory, I'm going to go right click new. What I typically do is just go text document and then I'll rename file and the file extension. So db.dss and then delete the .txt, enter, okay. And it now my computer recognizes .dss files as a file that would open up in DSS view. That's why you're seeing the icon there. All right, I'm going to make a copy for the state variable. You can just hold down Control and drag to make a copy in Windows at least, and then a init. So those are my 3 DSS files. That's good to go. For the other directory, I'm going to create a run directory, is what I called it. So run. And then inside that directory, I want to create my main Russell file. This is going to be the file that we referenced from the configuration. So I'll call it main.wresl. I want a directory called system, system. Okay. Inside that system directory, I've got 3 more files. Okay. And I created those off camera. There they are: variables, constraints, and objectives. So we're not dealing with channels or inflows or demands or reservoirs. We could really just write everything in the main Russell file. There's not a ton of code, but dividing the code into these 3 different components is good enough for this small problem. All right, so let's go ahead and start by defining the variables. Here is that file I just opened up. And what I'm going to do is just copy and paste in the code that I'm going to use. So real simple, I'm just going to define A, B, C, D, and E as the decision variables. This refers to the number of barrels that will be used to create a total of 100 barrels to minimize the cost and also satisfy those other hard constraints. Okay, let's go ahead and open up the other files now. Let me just open them all up. I think variables is already open. Yep. So here are the constraints. I'm going to paste them in right here. So I've actually added a label to just describe what each constraint is. The top one here, labeled on line 1, but written out in line 2, is the total barrel count. So I want the sum of A plus B plus C plus D plus E to equal 100 barrels. All right, the next one down is the minimum octane. So we need the octane to be at least 85. So what I'm doing is multiplying the coefficient for octane for each of the different types of crude, and then doing that for each of the barrels A through E, the crude barrels. So this is basically a sum product. And I've multiplied it by 100. Should really be a weighted average, right? So we have the sum product divided by the sum. But I'm just going to do it this way. So I'm multiplying it by 100. So instead of 85, this is 8,500. RIMS should be able to solve it both ways, but this is just a little bit cleaner because I didn't want to have to divide and then sum up all the letters A through E again for each of these constraints. All right, so the next constraint down, and I'll just talk about the third and fourth one together because they're so similar. We have a maximum allowable sulfur set to 70%, and then a maximum allowable benzene set to 80%. So again, these coefficients that I'm getting for octane, sulfur, and benzene, those were these coefficients right here. So we saw this table at the beginning just to introduce the problem statement. And keep in mind that in Russell Plus, the language, if you have a less than symbol or a greater than symbol, it's really just referring to at most and at least. So the value can be equal to, sort of like how I have it in my comments right here. All right, so that is the constraints. The objectives is the next file right here. So what I've done is added the decision variables A through E, representing the crude barrel in those 5 barrels. And then the negative symbol here, the weight is cost. That's why I made it negative. So these numbers here, 45, 35, 50, and so on, those are the costs associated with the crude that comes from each of the barrels A through E. Okay, we have one more file to edit. So I'm going to go up to the run directory, open up main.russell. This is going to create a sequence. We're going to call our model base, and it's just going to call the variables file, the constraints file, and the objectives file. All right, so that's good to go. I'm going to hit save. Let's go ahead and run it in RIMS and see what we get. So I'm going to, hold on, let me just right click and refresh first. Okay, just wanted to make sure that was good. And I also want to open up my DSS, my db.dss file where the decision variables will be written to, so I can get a before and after. File, open. Okay, here is the project directory, DSS, and then db.dss. Okay, so there's currently no paths. Let's go ahead and come back to this after we run the model. I'm going to right click on the launch file here and then come down to run as and then the name of the program. Okay, so that looked like it ran. Let's go ahead and check out what we have in our DSS file. I'm going to go up to View, Refresh Catalog. Okay, cool. There are my 5 paths, A through E, representing the 5 different types of crude. Let's open up the table data, and then boom, here is our solution. Very cool. So all of the rows are the same. So let's just look at the first row. It tells us that we're going to use 58 and a third barrels of crude A and 41 and 2/3 barrels of crude E to make a total of 100 barrels. It looks like we did not even use barrels B, C, or D. So that's interesting, but probably works out. So let me go ahead and run the debugger just to look at which constraints were active. Up at the top here, just select the first cycle. And then for the year, I'll select 1921. And yeah, September 30th should work. That's just going to stop after the very first month. So now let's go right click on our launch file, this time debug as, and then click on the first option there to run. It should stop in just a moment. Oh, I'm sorry. This is the last month. So it's still stopped. It says pause down here. It's giving me the debug tools. But what I want to click on is this tab here for all goals. Boom, all goals, and then click on this green C. So the green C popped up next to the specific constraints that are active or binding. And that is, of course, the total count, which we knew was going to be binding because that's an equality, not an inequality. And it's a hard constraint. And then the other one is octane. So this is interesting. It says that the octane is maxed out. That's a binding constraint, which means that this constraint here for maximum octane is active. And it also means that if we increase the right-hand side for this particular constraint, that we could get a lower cost, or you could say an improved objective function value. So, but increasing the allowable sulfur or increasing the allowable benzene would not improve the objective function value. All right, so that is it. That's how we solve the program. I'm going to just hit terminate there in the debug mode. We have our answers from DSS View. And now what I'm going to do is try to get these same numbers using Excel. So that's kind of the end of the exercise since this lesson is about RIMS. But if you're curious and you want to stick around and see how you would do this using Microsoft Excel, then you're welcome to join me. Only because this is a purely LP problem. It's not using a time series. RIMS is powerful and can do a lot of things Excel can't do or wasn't built to do because of the nature of the time series. So let's go ahead and show you how that's done in Excel. Okay, I had a table hidden down here, which I'm going to now reference, hide a few rows here. All right, so hopefully I can get this all on screen. Here's the original table up here. Here's a new table that I've set up for being able to set up the solver and make it make sense. What I have is across the top, I have the different types of crude. So this table here is a lot like the transpose of this table here, except I've also added this row for barrels. So again, we have the crude types across the top, and then the cost, octane, sulfur, and so on are the constraints, where we have cost, octane, sulfur, and the benzene. So these are the actual values from the table. And then what I've done here in the calculated left-hand side, I'm calling it, is calculated what is the actual cost based on the decision variables. So if you can see the colors, this is blue background, and these are the 5 decision variables. I've just initialized them to 0, even though that's an infeasible solution. The solver in Excel, just like RIMS, will take care of the slack variables, the surplus variables, and any necessary artificial variables if there's no initial feasible solution. So that's sort of LP simplex details you don't have to worry about, thank goodness. And then over here in column 8 here at the calculated left-hand side for the cost, that's just the sum product between the number of barrels and the cost per barrel. The next cell down is the total number of barrels, so that's quite simply the sum. And then for octane, sulfur, and benzene, just like the cost, what I'm doing here is creating a sum product. And then because it's a sum product instead of a weighted average, I'm again increasing or multiplying that right-hand side by 100. Excel likes it when I do this, and if I did an actual weighted average for this left-hand side calculation, it was giving me problems. So anyway, exact same problem. The right-hand side represents our limits. So we need a minimum of 85 octane and then a maximum of 70% and 80% for sulfur and benzene. Okay, let's go ahead and run it. This is the objective function value we're trying to minimize, and then these are the decision variables. Right now, we don't have our constraints satisfied, at least not these two, for number of barrels and octane. So let's go ahead and do that. I'm going to go up to the Data tab and then click on Solver. Now, if you don't see Solver, you can click on, hold on, let me open up the ribbon. Okay, and then scroll down. If you don't see Solver, you should be able to add that in as an add-in by going up over to File and then down to Options. Over here is add-in. So on the left panel towards the bottom, click on add-in and then click on solver add-in. And then click on OK. Yeah, I already have it added in. So your solver add-in may be down in this list somewhere. Hopefully you can find it and add it without any problems. Okay, so anyway, I'm going to click on the solver button right here. And now it opened up the solver parameters button. So this is where I'm going to define the simplex data, the LP objective function, decision variables, and constraints. All right, so I'm going to pull it off to the side real quick. As I mentioned, this yellow is the objective function value. That's what we want to minimize because it's cost. So I'm going to go ahead and click right here. It's asking for the objective function. Hopefully I can get this all on the same screen. And then just click on the cost right there. Boom, and it populates. You can also click on this button and then select it. Okay, so the objective, this is cost, so I want to minimize it. Then by changing values, these are the decision variables. So I'm going to click on this cell and I'm going to highlight the 5 decision variables representing the number of crude barrels. So that's set. And then down here, subject to, this is the constraint set. So I have 4 constraints. I'm going to go ahead and pull this off to the side so I can see the right-hand side. What I want to do is click on add, and the first constraint is going to be the total number of barrels has to equal 100. So I'll just say for the cell reference here, left-hand side equals, I put this symbol here in column 9 just to help me remember what to type in here. It's going to be equals for this first one, and then the constraint is going to be this value here for 100. And okay, so what it did is it added that constraint. I'm going to add the next 3 constraints in a row so I don't have to revisit this particular dialog box. So click on add for our second constraint. And then this is for octane now. So I'll click on the left-hand side. It needs to be at least, and then 8,500 or 85. And then I'm going to click on add. So it added it, and now it gave me the same dialog box. All right, so we're on to sulfur here. That's going to be this value that's calculated is at most, and then constraint is 70%. And then add, last one is benzene. Left-hand side is at most 80% and okay. All right, so I have all 4 of my constraints ready to go. Down below here, we can specify, oh yeah, non-negativity. Make sure that is selected. We can't have negative barrels. And then simplex LP is what you want to choose for linear programming problems. And yeah, that's all we need to do here. Let's go ahead and click solve and see what happens. Okay, so what popped up on my other screens, this dialog box right here, it says solver found a solution. We can also add in the different reports if you're curious about the answer, the sensitivity, and the limits. So I'll click OK to that. And I have some new tabs down here to give me the values, the reports. But what happened was it populated with the exact same numbers that we solved for our RIMS, which was a solution of 58 1/3 barrels of crude A and 41 2/3 barrels of crude E. And it gave us an objective function value of 3,875. And sure enough, we have our octane is an active constraint. See, these 2 constraints are active. We confirmed that when we were debugging in RIMS. But the other 2 constraints for sulfur and benzene, not a problem, not active. We have an extra, 3 1/3% of sulfur allowed and 13 1/3 allowable benzene allowed for this particular solution. All right. Well, anyway, that was it for this exercise. What we did was create a linear programming problem that involved fuel blending, and then we solved it in RIMS and then later here in Excel.